I'm Max. I live in the East Bay, and East Bay represent. Raise your hand if you came over from the East Bay for this. Thank you so much. We all ride back together. So I organize a couple things over there. One of them is every Wednesday, 1 block away from BART, we have the Oakland.js Meetup, shameless plug. And then we also organize the Node School, which is just nodeschool.io, and we do have an Oakland Node School. There's also have been SF Node Schools. But I'm going to talk about my project DAT, which is what I work on full time, and kind of show you guys what I'm using Node for. And that is how you spell my name. And just wanted to make sure to mention Node School because it's one of the open source projects I work on that everybody that works on it does it in their volunteer time, and it's a really great way to give back to the community. If you want to do one thing to help out Node School, go to our discussion board and click the watch button, and then you'll start getting emails from the newbies that are asking questions on there. And we need as much help as we can get answering questions. It's a really good way to keep your own Node skills up to sharpened, because helping people troubleshoot, and it's kind of an easy way to get into helping people troubleshoot, and you get really weird questions, and it helps you be a better developer. I really like cats also. Just want to show, this is a cat I took a photo of in Taipei recently. If you ever want to get into cat tourism, go to Taiwan. It's a great place for cat tourism. From cats to DAT, DAT is my project that I started about a year ago, and I started it as kind of a Git for data. So I wanted to have a way to install a data set, get a specific version of a data set, and also publish a data set. And the stipulation being the data set size can be unlimited, just however much bandwidth I want. There shouldn't be like a limit to the size of the data sets we can share, and make everything totally automated. So you don't have to write like custom scripts to do data munging or data plumbing. Try to like make something that's a nice tool to work with. And so there's two parts to that. One is sharing, and another one is collaborating. And they're kind of similar, but if you think of data sharing as like the git push and the git pull, and the collaborating is more like git merge and pull requests. And so I'll kind of talk about, it's inspired by Git, but it doesn't really have anything to do with Git, other than it's a 3-letter word that ends with T and has a vowel in it. But it's about a year old, a little bit, maybe a year and a half now. What's interesting about the project is we're not a startup and we're not a research group, like an academic research group. We're kind of a weird thing because we're a standalone open source project. And we have a grant from a foundation that pays us to work with scientists. So we work with scientists, but we're not ourselves associated with the university. But a lot of people think because we have a logo that we're a startup, but we're not a startup. So I like to say that. This is our team as of today. And we're basically, there's 7 of us, and we're all over the world, mostly Europe and West Coast. And we have a range of different skills, and a couple of us work on Python stuff because a lot of scientists use Python. And for instance, Bruno here, he works on his PhD, does DNA research on bees, and he's using Node on like supercomputers and using that to automate his research with bee DNA. And then we have like a really cool range of people. Like Matthias writes peer-to-peer code, like you can use Matthias's code to stream movies over BitTorrent and pure JavaScript. So it's a really fun group. And if you want to kind of see from the Node perspective, our whole project is built using Node. And we wrote some cool documentation for our Node modules that we use in DAT. So you can kind of see the internals, what modules we like to use, how we kind of built the thing. And the slides for this talk I should have mentioned are available online, but I'll tweet them out after, but they have links and stuff. So to kind of explain that, everybody knows source control if you've used code. And but has anybody, can I see a show of hands, have you done code and tried to use, like, send a patch to someone before Git? Do you remember the pre-Git days? All right, yeah. So it's almost like a war veteran kind of thing. So say you find a cool project and you find a bug, and then this is how you do it. You get like a zip file from a weird site. Maybe it's like mit.edu page, or it's like a SourceForge thing. You find somehow the code, you unpack it, and you manually edit it, and then you rezip it, and then you email the file back. And then there's not really like an automated way. then the maintainer has to manually merge your thing and then create a new zip that might contain your fix or might not. You actually have no way of knowing, automated. And it's totally messy. It's on the maintainer, it's actually really difficult too, because imagine a scenario where you're the maintainer and you get 2 emails in the same day from 2 different people that fixed different bugs in the same part of the code. You have to fix both of their code. You can't just fix the first guy's and then tell the other person, hey, can you rebase your code against the latest one? You have to fix both of it. And it's just totally messy. There's no way for you to know when you broke something. So then Git came along, and you could clone. They added all these verbs: clone, add, commit, push. They kind of just took the process and then turned it into discrete steps that are automated. And it kind of, this is like to me, Git is like a language for collaboration for like text files. And then GitHub came along and they solved the problem of emailing. So now there's like this open thing where you can see what other people have sent for patches. So before you go and fix something, you can check if somebody else has already submitted a fix that's pending. And it's just, it just made everything totally transparent and nice. But, oh yeah, and I should mention Git came first and then GitHub came later, obviously, but it's good to mention. And then what's cool is if your thing's out of date, you can just do git pull and you'll get the latest changes. And so then you don't have to, that 4-step process where you download a zip, you extract it, you figure out which files have changed, that seems crazy to us now if we're used to git pull, but that's actually what data sharing is like right now. So with data, it's like you find a server, there's like a CSV file that you might be emailing around. You might find a server that has some data on it. You might download it and then have to manually extract it and put it into a database with using custom code you write. And then the next day, if maybe the server updates a new version of the CSV, you have to write some sort of tool that either deletes everything you have and re-imports the new one or figures out what changes. There basically isn't a way to really get the diff and just do a pull. And then this is a way to do it too. You could just put your database into Git, but that's a pretty high-level way to do it. It works for some data sets, but as soon as you get to any sort of data set size, like medium or large, it starts to break down. So our project, the whole goal of our project is we're trying to figure out what is the language that Git came up with for collaborating on text files. What does it look to create a collaboration language for data sets? And the way we actually define data sets is, well, actually that's in a couple slides. But so data is a Node module, you can install it. The one major dependency that's other than Node that's not JavaScript is the database called LevelDB that we use to store all of our key values. And LevelDB is really cool for building these kind of custom things. And here's an example workflow with dat. You can say everything's on the command line. You could say dat init to create a new dat store in a folder. And then you can do any Unix pipe thing that either dumps CSV or JSON, and you can just do that into a dat import. And then to share your data, you do dat listen, and it starts up a server that you can clone from for somebody else. Or number 3, instead of a dat listen, if you have a dat on the other end already, you can push to it. So you can do dat push. And oh yeah, highlight. And okay, so I have in my computer, I have a folder called data, and in here I think I have, I think it's like genome. Yeah, so this is my 23andMe. It's actually not my genome, it's just a bunch of markers from my genome that tell me if I have different diseases and stuff. But I can look at you can kind of see what the data is. It's just basically a spreadsheet that has the value and then where in my genome they were, and then the ID for the position. It's just a different kind of ID. So I can take that data and put it into I can parse it using a CSV parser and then put it into a dat import. So if I first make a folder called .genome and then go into there and then do .init, it'll kind of ask me some questions about the data. I'll just use the defaults. And then if I do this command, then it will parse the data and then pipe them into a dat import. So it's I'm just using a Unix command to actually parse the data. First I convert it from TSV into JSON, and then I just pipe the JSON into a dat import with the JSON flag. And then it'll import my genome into the dat. And let me just actually cancel this and then do a dat cat, which just prints the data out. And so now I have my genome, but now what dat did is it added a version number. So if I go in later and I edit one of the genes, so I'll do a dat listen, and I can go in and edit one. We have like a little web UI that we use for just basically like it's a kind of Google Docs kind of thing. And oh, well, of course, live demo fail. But if I had gone in and edited my one of my genes to a new value, like I had a mutation, then there would be version 2, and then you could see, you could view different versions of the genome at different points of time. So the idea is that we version everything, and then you can get hashes that represent the state of the database at different points in time. You can also, once you have data up that's on a dat somewhere, you can clone it. So for instance, once you've cloned a data set and then the data set changes, like a week later, you can pull and get the latest version of the data set. And you can also, this is where we start diverging from Git territory. You can actually do a live pull, and that'll just aggressively fetch the latest data all the time as like a live socket, sort of. And then that's just for tabular data so far, so like CSV and JSON. But if you have large files, we have a separate store. So I mentioned earlier there's 2 stores in dat. There's the tabular store, and then there's a blob store. And blob just means big or binary large objects, just a file. And the difference is blobs can be any size, and you can stream them into dat, and you can stream them out of dat. And then when you do a dat pull or a dat push, it copies both the table store and the blob store. So you can have kind of heterogeneous data sets, and you can choose the right data storage thing for different types of data. And we store the tabular data in LevelDB and the blobs in what we call blob stores. And this has actually been really fun to write, the blob store layers. We started by writing an abstract API for a blob store. It basically looks like the Node.js API. It has create read stream, create write stream. I think it's only like 5 methods. And if you could implement those 5 methods on top of a file storage backend, then you can make a blob store compatible API, and you can just plug that into dat. And then now, so for instance, we have an S3 one. If you plug the S3 plugin into dat, then dat can just store an S3 for you, and you don't have to write custom S3 code. So we have all these blob stores we're working on for different use cases. The default one just stores on the local file system. Jacob Groundwater and I were talking today about writing one that does diffing between different versions of the file, so you only store what changes. And so we can do these kind of cool different implementations with the same external API. That's the whole idea. And then blob stores actually are pretty useful. They're not a dat-specific thing. They're pretty useful for general plumbing data with Node. And we also have a BitTorrent one, which is for, it's actually read-only. But if you load the BitTorrent blob store into dat, and then you give dat a torrent link and then a file within that torrent, then dat can clone. When you do dat clone, it actually uses BitTorrent to clone the file. So the sky's the limit with the types of things you could wrap the blob store API around. And so we're trying to just kind of create a little ecosystem of compatible modules for doing the same kind of thing, just moving files. And then some other stuff you get with dat is you automatically get a schema when you put your tabular data in. You get a free REST API on the data. And everything in dat is totally streaming because, I mean, it's built with Node. So we, like I mentioned, the dataset size can be super big. And it's not going to crash from running out of memory. And then, for example, I can talk about NPM. So we have npm in dat. If I go to like my desktop and I do dat clone npm.dathub.org, what this will do is connect to our server that we basically keep a live copy of all the data in npm, and we listen to the npm feed, and whenever npm publishes, we update ours. And since it's dat, you can just clone it. And so what happens is, as we process the stuff that we need to copy, we have to go fetch the files, the actual tarballs from npm. And so every time you see a change, that's like a new module, and every blob is like a tarball attached to the module. So like if you have a module that has 5 versions, we have to get 5 tarballs. But I can actually just skip, if I delete that and then do skim mode, that will only get the changes and it'll skip the tarballs. So I can choose to get the tarballs later with the skim flag. And this is way faster. I mean, we're getting like, there's only 110,000 modules on NPM. So you can clone all of NPM in like a couple minutes and work with the dataset locally. So the whole idea of this is like, this makes it really easy to do stuff like an NPM offline proxy, or just to code against a specific version of NPM at a snapshot in time, so that you can kind of introduce some reproducibility into your builds. And with the scientific stuff that we're doing, we work with a lot of researchers, and most of what they want is when they publish a paper, they can put a link in their paper to the data set they used so that someone else can verify their results independently and get the exact same version of the data set. So reproducibility is really important. And you can do some cool stuff with this data. Like once you have the data, if I go to this folder, I have just like a cooking show. I have the full data set already cloned. I can do, for instance, this program, which just uses the dat command line, or not the dat command line API, the dat Node.js API, and it just creates a read stream, which just iterates through everything in dat. And all I do is I just keep a running sum of the data. So the entire size of all the tarballs in NPM, and you can do it in like this. So as it streams through, it's just adding up all the tarballs, and eventually it figures out what the total size is. And then you can, oh yeah, that's the same code. So I showed you importing data. You can also export data, and then you can pipe it into whatever transforms you want. So we're totally Unix compatible, and we support CSV, JSON, and also a format called protocol buffers. We actually store protocol buffers on disk. So the idea is with protocol buffers, if you have a certain type of binary schema, like 64-bit integers, JavaScript doesn't support that, but we can just store that for you anyway. And as long as we don't convert them to JavaScript numbers and you try to do math on them, everything will be fine. And what's cool about Unix stuff is we can use stuff like Docker. So we can actually, we can cat data from dat directly into a Docker container that runs some pre-built stack of dependencies inside of a Docker image. So then you can do compiled code cross-platform with reproducibility, because you're not having to install like special versions of Python or whatever. You can just use a pre-built Docker image. So for instance, I can render some screenshots of Markdown from readmes of the NPM data using this module that's a Docker container that takes in Markdown and then creates a screenshot of GitHub flavored Markdown as a PNG, and then gives you a tarball with the PNGs. So if I do, where is the command? It's like this, it is history. Where is the thing? It was like, oh wait, actually I have it in this shell script because I knew I would forget it. Right, so basically what I do is I do a dat cat, and then I get the keys that are greater than equal to dats, and I get the first key, which is greater than equal. I'll actually do 5. So we get 5 readmes. It'll be like modules that start with dat and then dat dash something. And then I just pipe them into this Docker container, and then I pipe the output of the Docker container into a tarball. And so this takes a second to run. So it spawns the Docker container, spawns dat, and pipes them into each other. And then now if I look in this folder, I have this tarball that was just created. And if I extract the tarball, then I'll have all these PNGs of the readmes that it found. So it generates like these PNGs of the readmes rendered in a little headless browser. So you can kind of automate these kind of scripts that are super annoying and make them one-liners pretty easily, and make them cross-platform. So this will all work on Windows, by the way, and Linux and Mac. And so yeah, like you can see, it got the first 5 modules with dat dash something plus the dat module. So we also made an online thing to learn dat. If you want to play with dat without installing it, there is this tutorial we made. So we actually do some kind of crazy stuff. We spawn a Docker container with that installed for you when you load the page. And we give you an ID here in the URL, so you get your own virtual machine running with dat on actual Linux and your roots. So you're logged in as root to this machine, but it's Docker, so we can like make it so you can't delete everything. But we give you a file system, so you can say like npm install unique, like the unique module. And if I do some stuff on the server, it actually syncs it down here to this little text editor we wrote. So then you can go and see the file system and play around and edit the code. I can go in here and say like console log like hello, And then if I go into the node REPL and require the unique module, then it'll print my hello. So it syncs back and forth. And you can actually do like require HTTP, can't type, .create server, and then do like a little web server and listen on port 80. And then if my web server just says like res.n, oops, like hi. So I'll just make a really dumb little server, and then if I take, we give you an address for your instance, and if I open that, then I'll have a little server running that says hi to me. So yeah, it's super fun. You can try it out at Get Dat. If you just go to the Dat README, you can find it. How am I doing on time, by the way? I'm done? Okay, cool. That is all I wanted to show really anyway. The last thing I want to say is we're all open source, and we're over in Oakland, and we're going to be at JS Fest next week. Come out and talk to us, and I have some stickers after the talks. So thank you.